Alright guys, so we are learning about random variables today, okay? We're talking about discrete random variables and probability distributions. So basically, we want to define what is a random variable, okay? This word random variable, okay? So that a random variable has a quantitative variable whose value depends on chance. So it's a quantitative variable whose value depends on chance. When they say chance, most of the time in AQR, okay, mostly we are talking about probabilities, okay? So with that said, now let's say that with the notation x is a random variable, y is a random variable, and z is a random variable, okay? Now this is a typical example. We are saying that the siblings over here is represented by x, okay? Siblings, okay? That is represented by x. We are saying that, so there is a family, about 8 families have no siblings, okay? 17 of them has only 1 sibling. Then 11 of them has 2 siblings, and then 3 of them has 3 siblings, and 1 have 4 siblings. So 4 siblings. Now we want to find the probability. The first thing you have to do is add all the family, which is 40 different families, okay? For us to find the probability, we just take the frequency, okay, which is 8 over 40. So you see that it's 17 over 40. 8 over 40 is 0.2. 17 over 40 is 0.425. 11 over 40 is 0.275. And then 3 over 40 is 0.075. And then 1 over 40 is 0.025. Okay? This is pretty straightforward. So just take the frequency divided by the total frequency. Okay? That's how we find the probability. Now, there's something you have to know. When you add all the probability distribution, you are supposed to get 1 in the discrete sense. Okay? So for us to represent that mathematically, this is what we say. Okay? We are saying that if you add all the probability of the siblings, it should be equal to 1. So don't worry about this summation. The summation means you are adding, basically, okay? Summation of all those probabilities, like we see in the example. Watch. The example we have here, you add 0.2, 0.425, that 0.025, and all of this. You are supposed to get 1, okay? So that's for the probability. So sum all of them and you get 1 out. The next thing we want to discuss is histogram, okay? So based on what we already have, okay, this is how we draw the histogram. So this is when a family have only 0, has no sibling at all, or have one sibling only, or 2 siblings, 3 siblings, or 4, okay? Then under that condition, okay, we notice that in the first family, about what? So I'm taking this, so about 0.2, okay? When there were no siblings, the probability was 0.2, so we had 0.2. So if you look at the histogram, I started from the middle here, go all the way to 0.2. This is 0.1, this is 0.2, this is 0.3, this is 4, and this is 5. So you notice that 0.2 is for the first family, okay? So this is how we draw a histogram, okay? Then the next family is almost like 0.4. Let's go back and look at it. This is 0.425, okay? So since we are looking at 0.425, this number in the histogram, you can see what I will do. So on the histogram, I'm drawing from, so on 1, I'm looking at from here all the way to 0.425, which is a little bit above, somewhere over here. Okay, that is why this is like this, okay? Then the next one is, when we look at the number, that is for the third one, is 0.25. Okay, so 0.25, so 25, this is 2, so 25 will be somewhere over here. And then we have 0.75. So this is 0.75, and then the last is 0.025, which is somewhere small over here. So basically, when you're drawing the histogram, you can even go online and check on histogram and how to draw them with the probability. Okay, if you don't get what we are looking at, okay, and then look at expected value and probability distributions. Okay. Now, this is an example that I want you to try. Okay, so here we have grade levels, okay, and we have frequencies. Okay, you know how to calculate the probability. Just add everything. So each probability distribution will be this, add everything and divide by this divided by everything. So now let Y denote. Okay, so this word is denote the grade level of a random selected elementary student. Then Y is a discrete random variable whose possible values are 0, 1, 2, and 3. Okay, so this is what it said. So this is the question. Okay, have a look at it. So now the question is so this question, try and do the histogram and the probability distribution that we're talking about. Now, expected values. We currently are doing expected values, okay, and odds. So in probability model M, suppose that the possible outcome S1, S2, Sn are in a sample size are numbers Pi, okay. The probability of an outcome Si, the expected value of that probability model is called so P1 times P2. Now, all they are saying is that each of the elements that is given to you have their own probability, so you just have to multiply them. Okay, let's see if we have an example. So this is a probability. So let me turn this and show you what I mean. Assume that if it rains today, okay, and I have a party, so I have a party, 12 people come if it rains, right? And if it does not rain, okay, if it does not rain, only 20 people come, okay? So 12 people come when it rains, and only, but the probability that these 12 people will come is 0. The probability that it will rain, okay, is 0.4, and the probability that, since it's 0.4, the probability that it will not rain will be 0.6. If you want to add both of them, okay, so that's basically what we are looking at, okay. So the expected value, okay, is equal to 12 times 0.4 plus 0.6 times 20, okay. That's what we mean by the expected value. So you just take the number that you have, which is, this is x1, x2, and multiply by p1, p2, okay. Remember, all of these things that we are teaching are online on YouTube, okay. So you can go in and type expected value and see how they explain it over there, okay. All right, so probably watch out for the next video tomorrow, okay. We just want to keep the video short, 10 minutes. All right, I'll see you guys tomorrow.